Welcome everybody. Good morning. Great that you could join this webinar from EnSav, and we're excited that you are on the call. My name is Frans-Willem de Kloet. I'm the co-founder of EnSav, and I will say a couple of times next, and I will introduce also the speakers to you. But next is for the next slide, because we have someone doing that for us. So next, please. Ara. Yeah. Anyway, so. I said I'm representing EnSav. We are a young company, just founded about a year ago, and EnSav stands for Energy Savior, and that's exactly what we do. We try to save, support companies in saving energy, grey energy to be exact, in reducing energy consumption and also adding energy production from new renewables. We operate currently today in 5 markets: Poland, Germany, Belgium, Netherlands, and also in Kenya. And before going to the speakers, I just wanted to give you a quick view of the agenda. So I'll do a couple of words about EnSav, what we do, our view on the market, and then we have a lot of time to discuss the topics of energy deregulation. We have Gerrit Buys today with us from Claes & Fox. Gerrit is an advisor for companies and also governments in this area. I hope you will find it very interesting. It's a very different view on this energy market, and hopefully also inspiring in what else you can do once you start thinking about energy saving and energy production. And we also have on the call today Stefano Neva. Stefano is representing one of our key technology partners in voltage and power optimization. He will explain a bit more about what it exactly is and what it does and how you can save energy with that. And also will come with a case to give a bit more light to how that would work also in combination with solar. At the end of the session, hopefully we have enough time to do some Q&A. You can already ask questions to us through the Q&A button downstairs, down at the Zoom call, I would say. And then we can go through it at the end of the call, or you can also be unmuted at the end to ask your questions in a personal way. Next slide. Yes. So very quickly, our mission: we would like to implement and integrate innovative solutions. So our aim is to have very innovative and patented solutions for our clients. I think the key word here is integration. What we see a lot is that a lot of the solutions offered in the market are very point solutions. There are certain technology, either solar or energy saving or storage, but we believe that ultimately the best solution, the best systems are if you do it in an integrated way, and then you get the most optimized way of doing it. And we also look, of course, at the financial values, because we also believe that the best way to save energy and to save on the, let's say, the dirty energy in this world and on CO2 is if there's also a financial value behind it. Next, please. So what do we see actually in the market? We see quite a few concerns with the customers we talk to. And one, of course, clearly, and the first one is the rising energy prices. I would say at least 80–90%, and I think there's also some research on it, most customers, most people expect prices of energy to rise in the future. Either because of CO2 taxes, whatever, but the prices will rise. And it's a concern for companies because more and more the energy is a key part of the total production cost. Associated with that is the concerns around power quality and outages. With renewables, the power balancing, and Gerrit will probably talk a bit about that, the power balancing will start to change. If you look at the main grid providers across all markets, if you look at their annual reports, it's very clearly stated that they are very concerned about the flexibility they need to provide to the network. It's very simple. If the sun is shining, more and more, there will be more power on the network, and there will be balancing issues coming to that. And we can expect, and companies are expecting, that there will be more power quality and outage issues going forward. And not alone that, I think also climate change. Look at Texas, what happened just a month back. these are serious concerns companies currently have because it will affect their production. So that's something we talk about a lot. Then, of course, as of this year and for the next, 2030, 2050, there are very strict policies around CO2 reduction. You all know the targets Europe has set itself for the coming years, and we are expecting that as of this year, especially these kind of regulations will come in place, and that will have a cost implication on companies. So CO2 reduction, greenhouse gas protocols, all these kind of things will become a very important element for any company to think about. Then, of course, Then, of course, the production of renewable energy and the optimization of that is a key topic. Solar on roof. You see also in countries that there's more and more discussion about putting solar in fields, wind energy, and we need to find also ways to use the roofs, for instance, of companies to produce a renewable energy. And finally, and Gerrit will talk about that, is how can you take more direct control over your own energy and the power balancing? It is also an opportunity for companies to work with that. Next, please. So this is, very quickly our offer. So we work with all sorts of technology partners. We basically start from the bottom. Look at what is the current energy situation, energy system of a client. How can you, monitor that better and actually already save some energy by monitoring your energy consumption? Looking at how can you save energy and ultimately go up to energy production and also energy storage. So that's what we do as an offer. Next, please. Yeah, and then last slide from my side is, what is our view on the market? I think everybody can say that energy transition is inevitable. It is only starting, and there is a lot of change going to happen in the next coming years. And it's important, I think, for all companies, governments, people to think about what is this going to mean for them. And as any major shift in a business, also looking at, let's say, major changes in other industries, there will be ways to benefit from this. Yeah. So if you think about it, and Gerrit hopefully will also share some light on that, there are definitely ways to benefit from this transition, but there are also ways to lose out. So again, I think the point of this call and this webinar is also to think about it and to think what this could potentially mean for your company. We also believe that it's not only about return on investment and paybacks. It's not only about financials. Yeah? It is also about thinking, what can you do if you save energy? What can you do with the energy you saved? Again, hopefully we can give you some elements to think about today. And finally, as already said, point solutions, only having solar not necessarily provides the best benefit. Just to think about it, if you have an outage and you have a solar panel on your roof, it will stop. It will not provide you energy. So you need, for instance, also to have a storage solution to make sure that once you have an outage, the company can still continue to work. So that's also something we believe and what companies need to think about. Next, please. Next, please. Yeah. Anyway, so that's it from our side. Again, we didn't want to make it a very commercial speech, just that you have a bit of an idea of what we stand for and what we do. We have two great speakers, as already said today on the call. One, Gerrit Buist, partner at Clayton Fox, advising governments and also companies really in this space of deregulation and how you can benefit from all these transitions also from a financial perspective. So very happy that Gerrit is there. He is in the energy industry for all of his life, working for, again, universities also, and also founded some companies himself. And on the other hand, we have Stefano Neva. Stefano, as said, is our partner, one of our technology partners. He also has a background in solar. That's not mentioned here, but I think it's also good to say, because again, it's important that we have this integrated view on our market. So with that said, I am very happy that you could join this call. Gerrit, I can give it to you.
Yeah, thank you very much, Frans-Willem. Next slide, please. My name is Gary Buist. I'm from Claes & Fox. We work mainly in Northwestern Europe and North America and Southern Africa. Our background is finance, energy, and data. We're quite boring, and we have a very simple story to tell in a world where lots of things are going on. The title is Deregulation of Energy Market and Impact on Pricing. I expect now 5 participants are leaving our audience. I hope the rest will stay, because it is an interesting story we have today. We have the combination of technology and contracts, commercial arrangements. I will focus on Belgium, Germany, Poland, and the Netherlands for a simple reason. Belgium is a nice example of what regulators can do wrong. Germany and Poland are the center for Europe and the center for the developments in Europe. And the Netherlands is the smallest country you can imagine below the sea. And it had to improvise on many developments. I shortly will try to paint to you. Next slide, please. Like Frans-Willem said, many things are going on. And it will take many hours to go only to the top of those issues. I will discuss with you several developments, but mainly one thing will not change. When you are an industry, you are a consumer or you are a generator of energy. If you don't do anything, depending on the market, you will be a consumer or a generator. And prices might rise, prices may go down. It depends on your position whether you're going to benefit from those developments or not. And it might depend on your shareholders, perhaps it's your own company, whether you will benefit of it or not. The energy markets are opening up. It used to be for about 150 years since we started the electrification of the energy markets that there was one vertical integrated monopoly. Every country in the European Union, but still in most countries over the world, are vertical integrated monopolies. I specifically focus on electricity because of the electrification of what we see around us for consumers, households, and industries. In those vertical integrated monopolies, mostly the state was the owner of large generation, the distribution, the grid, so to say, and they also determined what prices people and companies were expected to pay. They were really monopolies. And they could be so because, especially after the Second World War in Europe, it were the governments who had to make the investments, huge investments for coal-fired power plants. And every country had several of those big, large coal-fired power plants. Later on, you got gas-fired power plants, and all those monopolies worked on rather well, because in Europe there was a big development for electrification. And then things started to change by technology, but also by the wishes of those consumers. And the developments were, you no longer needed to be very big to become your own generator. You could do it yourself. And the market changed. They started to change in the Netherlands rather late, in 1998. And in the UK, they started at the beginning of the 90s of last century. Now we see in Germany and Poland quite some developments, and also in other countries in the European Union. I'll come back to it later, but the European Union is very clear in its message. If you don't do it yourself, expect some very unpleasant surprises. Industry and demand and industry supply is on the rise. Like I said, it's now much easier to generate your own power than it was 10, 20 years ago. It was much easier to become your own supplier, to make sure that you benefit of your own consumption of generation than it was in the past. And especially where you see big industrial clusters of industries, it is interesting to start cooperating. There are still quite some difficulties in Europe. When I focus on Spain, on France, on Italy, I see still large energy companies. When I mention Mitsubishi, the owner of large energy companies in the Netherlands, and Eco, Sweden is Vattenfall, Germany, E.ON, and France, of course, Électricité de France, Energy de France, they still dominate the markets. And perhaps those governments will insist on the continuation of those domination. But we also see at the markets now new developments. Next slide, please. And there you see that no longer it's only those large incumbents who dominate the markets, but people start doing it themselves. So no longer centralized steering, a government that determines so-called demand and supply curves, but decentralized solutions. And it all started with industries. The moment industries started to realize that their production process is a set of cash flows, the production process is a way of making money, people started to think, how can we become more independent of those incumbents? Those incumbent energy companies, they are mainly interested for their own shareholders. But if you're an industry yourself, why don't you tap on the opportunities you have in your own production process? You make your own energy first, rather than support those international energy combinations. And there's also another development. What we saw in the last 10 to 15 years in Europe, that financial regulators started to look in the operations of those large energy utilities and the consequences of their dominance for the end users. Financial supervisory agency said to the German utilities that they were quite they were financed in a very intriguing way and not as it should be, that they had big risks and that they wanted their clients to countervail for those risks. I will not bother you with how boring financial supervisory rules can be, but it's changing the markets. Another thing that is changing the markets is data and speed. What we now can do with data collection, with our databases, you couldn't dream of 20 years ago. And even 3 to 4 years ago, your databases were quite still slow. Nowadays, what we can do with web services, it's amazing. You can have more data to your own discretion than the large industry incumbents had it 10 years ago. Next slide, please. So it's time to start to think of how do you take control and how do you invest in new technology. You need to understand the technology in your company. If you don't, well, probably you weren't in your business too long anymore. But if you do and you understand your business, and most entrepreneurs do understand their business, you can now make investments that weren't possible some years ago. And they are not that expensive, because always bear in mind, sustainable forms of energy will bring you more profit than the fossil ways of energy, the old ways of energy. If you want to be in control, if you want to be flexible, it makes you more profit to rely on yourself, on savings to start with, and to benefit from your own generation capacity and from your own consumption patterns. Next slide, please. You need to know, how do you deal with your energy position? Where do you buy your energy? For what consumption do you buy your energy? And for what generation could you buy your energy? And it might be the experience of some of you that large utilities are not the most client-focused companies there are on the world. And at the same time, there's a huge change in all technological developments, the metering, the sensors. Stefano is going to spend more time on it. It's great what you can do. It doesn't cost that much money. It costs you time and it costs you space in your brain. If you don't use your brain, it doesn't matter what kind of technological changes you make in your production process, is not going to benefit you. But if you use the opportunities there are, you will benefit from it. There's another pressing concern why you should start thinking about the developments of the energy markets, the climate change concerns. They are no longer only concerns of some politicians. They are now vested into law. If you don't change your production process and you are an energy intensive company and you affect the climate change, you will have to pay for it dearly. And you will pay for it dearly unless you start to take control about your own energy opportunity. The governments in Europe, the European Union, the European Commission especially, are now focusing on what you need to do on your own efforts for climate change control. That means also further liberalization. Liberalization is normally a term for politicians, but it means that other players will come to the market and will start offering services you wouldn't think possible for a couple of years ago. There is an open access to the energy markets. And let's face it, the energy market is no longer only the Netherlands or only Poland or only Spain. Europe is connected. Frans-Willem was mentioning Texas. You will not see the Texas situation that soon in Europe. Texas was like an island. There is no island in Europe. But it also means for you as an industry, if you don't act and follow the developments, you will be late. And as an energy intensive company, that might cost you dearly. Next screen, please. Our advice is simple, quite boring. You need to start with two things: technical improvements and be aware of the commercial arrangements you are in. Technical improvements, I'm a lawyer by background, so what do we know about technology? Not that much. We know quite something about data, but not about the real hard, interesting stuff. But two suggestions: installing new interconnections and implementing smart energy technology. So making you yourself in charge of your energy position is a very good start to focus on the other leg, the commercial improvements. Have you ever checked your contracts with your utilities? Have you ever checked the contracts you have with grid companies or with other agencies involved in the country where you're active in? If you really want to be energy efficient, it may be worthwhile to start selling power surplus to your neighbor. Or if you want to do something with storage that you can buy from somewhere else or to sell to someone else. And in that way, you start improving your operational profits you couldn't think about several years ago. Next slide, please. Europe is boring, is expensive, and is pressing. If you see those 5 bullets, from energy performance in buildings to electricity market design, and you don't think about it, you might lose out on that market. And that market is big. The European Commission expects the total amount of investments to be around 1 trillion euros. It's quite a lot of money. But the transition away from fossil fuels towards cleaner energy is clear. It's going to happen. It's not only going to happen because politicians want it, but it's going to bring money to those people who are really committed to reducing those greenhouse gas emissions, because they realize they are entrepreneurs. You can make money out of it. Governments in Europe focus on it, focus clearly on it. You will see new energy laws, any member state in the European Union. Energy efficiency and capturing renewable energy is going to be key in it. If you're not able to measure your performance, if you don't have the contractual openness to start operating in this area, it's going to be difficult. Electricity market design, energy market design is a very clear message. Everyone can do it. Everyone should do it. And everyone should be responsible for their own energy positions. Now, talking about those positions, next slide, please. This is basically it. Who pays whom in the electricity system? The consumer, from a financial perspective, that's a short position. And they have generation, that's a long position from a financial perspective. And any one of you is sometimes a consumer and sometimes a generator. Because bear in mind, if you have a contract but you don't consume under that contract, someone is going to sell out of that contract. So financially, the generation position can offer financial opportunities, just like the consumer perspective. And wherever you go, and we work in quite some countries, there's always a function called, in most countries, supplier, or a similar term, or a balancing responsible party. That's the trading party. Keep it simple. The supplier is your administrative office, and the balancing responsible party is the trading. The trading, who is in most jurisdictions responsible for having the contacts with independent system operator to make sure that everything is balanced. The independent system operator is the balancing authority, and the BRP is the entity in charge of submitting programs enabling the ISO to keep the system in balance. And wherever you are, there is a taxman. The tax authorities on quite a growing chunk of your tax, of your energy bill. And you need to pay your local grid. if you do not know how much you consume or how much you generate, you do not know how much you are paying to the local grid or how much you need to pay to the tax authorities. So you better know it yourself, or the tax authorities are going to determine how much money you need to pay, and the local grid will determine how much you need to pay. And be very simple. If you are an energy intensive industry and you have neighbors, why don't you become your own supplier and your own BRP? These are the functions you will find everywhere. From Europe, US, Africa, everywhere in Asia, everywhere there's always someone who sends out an invoice, and there's always someone who is trading. Bear this in mind, who pays whom in the electricity system, and you will understand that having the combination of technological improvements and contractual freedom is giving you a very good position. Next slide, please. Clean energy has a clear message. Energy saving is making money. You need to do something because the deregulation won't stop. New market rules will come up, and you have a choice. You can make your assets work for your own profits, or you start supporting with your money, with your energy assets, the local energy utility, the local energy company, like it was the last 50 years. But investing in energy saving equipment, combined with insight and access to the market, is key to profit. Understanding those clear function and who pays whom will be the start for you and your company for hopefully being profitable in this new market era where market prices might go up, might go down, just like in any other normal market, and it can be good for you. Thanks for your attention, and if you have any questions, please do so at the end. And I will introduce Stefano Neva, because without technology, no commercial contracts are really sensible. Thank you.
Thank you, Gerrit, for the introduction. I just took a few bullet points while you were speaking, and the interesting part is that the landscape is really changing, okay, and the new form of energy production and grid management are really affecting also the energy saving market, and that's one of the topic that I am going to cover now for my part, which is about power quality. So, as said, today's topic is power quality. We will try to highlight a little bit what it is, why it's important, and what we can do to improve it. We can say that, like any other raw material in a productive system, it is important to control and improve the quality of the electric energy in order to improve the quality and cut the cost of the production output. If you can go on the first slide, Ada, please. Thanks. According to Leonardo Power Quality Initiative, which is one of the leading initiatives taken by the European Commission, a poor power quality will cost around 150 billion annually on a European level. But this is not just a topic of Europe, as Gerrit highlighted, but this is a global trend. So not surprisingly, energy managers all around the world are becoming more and more aware of this topic and aware of the benefit that a good power quality management can create. But now we have to define a little bit what is power quality. And generally speaking, of course, this is a very large topic, but just to go into the details a little bit, we can see power quality as the compatibility between what comes out of an electric outlet and the load that is plugged into it. So in other words, we can say if the energy that comes out of the plug, okay, so to speak, doesn't match the requirement of the appliances that are fed by that energy, we have a power quality problem. and specifically in terms of most of the times in terms of voltage, frequency, of waveform of the energy supply. Why it is important to have a good power quality? It's important because we can have a large number of different problems related to the features that I already mentioned that can lead to damages of the appliances and to waste of energy, and therefore, of course, waste of money. So we can have harmonic distortion, which are distortion of the normal waveform that are created by nonlinear loads, specifically by electronic loads. As Gerrit mentioned, companies are applying electrical loads more and more. So we are going through an electrification process, and specifically through electronic loads. So we are seeing companies putting more and more electronic loads into their systems, and this is creating, of course, a problem of harmonic distortion that can lead to problems with motors, etc., etc. Then we have other kind of problems related to what we call transients, which are very fast high voltage increase that may lead to the rupture of motors. We have very frequent frequency variation that can change in a very short amount of time, going up and down. Then we can have also other factors related to poor power factor, over voltage situation or under voltage situation, meaning by that a constant situation of over voltage or under voltage. We have a voltage fluctuations with different kind of fluctuation. We will not go into the details because we will take a lot of time, or we can have some phase imbalance as a problem. All of these last topic will belong to a broad category that we call voltage optimization. This is the field of application where EcoPower, which is the company that I am representing here, is focusing on. And I will show you how voltage optimization can be considered part of a good power quality management system. So next slide, please. Okay, so why do we say that voltage optimization is so important? You may know that voltage supply is not stable by nature and can be influenced by several factors, such as, for example, the distance between the source of energy and the consumption point, the number of users that are attached to a specific line, the length of the cable, the dimension of the cable, the age of the cable. So there are a lot of factors that will influence the voltage stability. So these fluctuations, and in particular the peaks of this variation, can lead to several problems. And these are the problems that we are trying to address with the proper voltage optimization management system. So first of all, one of the problems is that we can have an extra consumption of energy and therefore a waste of money on the loads that are voltage dependent or voltage sensible at different degrees. For example, motors, pumps, chillers, resistance, transformers, and lamps. Of course, as you may know, all these loads can have different degrees of sensibility in relation to voltage. In other words, they can behave differently at different voltage level. We can say that independent authorities have already certified saving between 5 and 15%, depending on the situation, by managing these over voltage peaks and constant over voltage situation. Second important point is that this fluctuation can have an impact, a very high impact on the lifespan of the devices. shortening up the duration and creating extra maintenance cost. There are a lot of studies that shows how an extra voltage can lead to a premature wear and tear of the electrical devices, to extra maintenance cost, and to extra cost related to the fact that the devices are going to break up a lot more often. Next slide, please. So in the short term, the application of a voltage optimization machine or device may lead to several benefits. Number one, of course, which is the one that everybody is most interested in, is the saving of money, which is probably always the number one topic when a company thinks about an investment. But of course, there are several other benefits to consider, such, for example, the protection of the equipment and overall a better operation in terms of also reactive power, harmonic distortion, because these devices also have a benefit from this point of view. We have benefit from the protection of the environment, reducing the footprint of any productive activity. As Gerrit mentioned in his presentation, there will be more and more pressure from the politic in general, from the government, to look at what we call the ESG criteria, which is environmental and social and governance, to give credit to the companies based on how well they perform, even on environmental base. So we do not have to think that these are only topics related to energy management and very technical topics. These are issues that will be impacting all the life of the company, from the supply to the cost scenario to the overall let's say range of application of the entire life of a company. So the thing is that what you really need to do is to have an approach that will try to keep in consideration all these kind of topics. Another important point is the fact that built in the system, we have a monitoring system to improve production management. Then you can create KPI, best practice, etc. All this data, this is another important point that also Gerrit made. Now we are in a data age, okay? It's important to manage energy, but also to important data. You can collect all the electrical data of your company and merge this data into BMS, which are building management system, EMS, that are energy management system, or even blend this data with the data that are coming out from your SCADA systems. So these are obviously machines or devices that are taken into consideration, especially from a financial point of view or an economic point of view when we're talking about ROI of investment. But we would like you to consider also the other features of these machines from a data management point of view or environmental point of view. So as a conclusion, power quality and in particular voltage optimization can no longer, in our perspective, be ignored in a modern energy management system. The benefit of this implementation are well documented and economically and financially sound, and should be considered by any energy managers that wants to seriously take into consideration the opportunity to bring an extra value to his own company. So this is the conclusion of my topics. Thank you. would you like to go directly to the business case? Okay. I would like to show you in practice how we translate all the things that I explained to you into an actual business case. We are now dealing with a large company in Italy, but this is an international company that has several production sites all over Europe. They are a large paper producer. They are consuming more than 2 terawatt-hour every year of electrical consumption only. Of course, we are not applying our machine on all the consumption. Some of these consumption are directly in high voltage or medium voltage. We are only working on in the low voltage side. But this is a complex case that can show you how a power quality management system can lead to impressive savings, because we are solving a lot of different issues, a lot of different problems for our customer. In particular, if you take seriously what Gerrit said about local generation, and you are considering the possibility to implement what we call a DER, which is a local generation system, a decentralized energy resource. These are the topics that you may be interested in. So, for example, the problems that we solved for this company, first of all, we reduced to zero the penalties for reactive energy. Because of the fact that they have large photovoltaic plants, okay, they have a problem with a reactive energy penalty. This is created by the fact that, as you may know, photovoltaic plants are creating energy with a power factor of 1. So it's, let's say, doesn't need to have any power factor correction, but this is creating the fact, as you may see, that the same amount of reactive energy will be counted by the utility meter, and by the fact that they are taking less energy from the grid, this will change the ratio between active and reactive energy, and their overall power factor will drop below the penalty level. They are paying something like 130,000 euros every year as a penalty, and I will show you later how we are going to cancel this kind of penalties by an application of a special power factor machine. Next slide, please. Okay, another problem that they are facing is that a poor power factor is leading to an extra consumption of gas, because they have a lot of big cogeneration plants. They need to create more kVA that are the apparent power required to run their motors, because of the fact that they have a poor power factor, and therefore they need a lot of kVA, they need a lot of gas, they need to run these motors at full speed to be able to provide active power to the motors. And therefore, if you see the comparison here between two different power factors, by enhancing the power factor, we are able to reduce the total apparent power needed, and therefore, generating locally this power, they will save gas. Normally, you don't take this into consideration when you are just relying on the grid sources, because the grid will only make you pay the apparent power only if you have a bad ratio between active and reactive power. But when you are creating locally your own energy, this will change the entire perspective. So in this case, reactive power management is directly an energy saving technology. Next slide, please. Okay. The other problem is that by having a lot of local generation plants, they are closer to the source of energy, and as we have seen before, being closer to the energy source will create a situation where your voltage, your supply voltage is very, very high, and as we have seen before, this will lead to an extra consumption on all the devices that are voltage dependent or voltage sensible in some degree. All of these problems, next slide please, is creating a situation where they had an extra consumption that we are addressing at the moment of nearly 3 million euros every year that are related to electric saving generated by the EcoF solution, which is a voltage optimizer. And then we have the reduction in reactive energy penalty. And then we have an extra production from cogeneration and solar given by a better power factor management. So obviously, this is a very complicated project. It will take a rollout period of 3 years approximately. There are hundreds of installation. We are going to install hundreds of machines, different sizes, different positions, different lines, etc. But the overall overview of this project is what you've seen. By managing power quality, we are really able to provide measurable, and this is the most important part, savings for our customer. Next slide, please. Okay, this is, let's say, the last sentence that I would like to leave you with. It is extremely important to have a measurement protocol that is very solid, very accurate. We are working with the leading protocol, globally speaking, which is called IPMVP, that some of you may be familiar with. But we think that unless you can certify your result, we are only talking about opinions. When we measure and when we apply a protocol, we are talking about numbers, we are talking about ROI, and we are talking about strategies. We are not in the field of opinions anymore. Thank you very much for your attention, and if you have some questions, we are more than happy to answer to you.
Absolutely. Thanks, Stefano. Thanks, Gerrit, for this very good overview and bringing us to some of the ideas and views on this market, especially around energy saving. Maybe just as a quick summary, and then we'll open for questions. We have around 5 minutes left, and we already have a couple of questions on the Q&A. So I think again, if the future is changing, I think, and that is normal. The landscape is changing in energy, and we are very excited actually about that transition, and I hope you are as well, and especially also after the great talks of both Gerrit and Stefano. But I think it's the key point of what we wanted to stress today is that it's not only about investments and ROIs and paybacks and meeting CO2 requirements from the government and so forth. It is, I think, in Gerrit's words, I think it's important to realize that if you spend money on saving energy, if you do an investment on saving energy, or if you are in energy production, you can do something with that energy. You have the choice either to, if you save energy, to give the energy back to the energy company and let them make the profit.
May I interrupt you? Or, you don't give it back, you sell it. Never give it away for free.
Or you have, so that I think one of the key messages we want to bring across today, and that's important as a company, most of all, I would say, as a business, to think about that and how you can benefit from that. I think one other point is, it's also important to, in this same game, to understand that if you invest on energy saving, it's often it's cheaper than energy production. So keep that in mind if you invest in systems. But most of all, look at the combination of all these things, because that will actually really bring you the benefit. And then in combination with what Gerrit was saying about deregulation and take your own control, then actually you're using this future and this changing landscape and this energy transition to your real benefit. And that, I think, was the point of today, and to bring that to you across. And with that, we would like to open maybe for another 5 minutes for some questions and answers. We already have some. I'm not sure if anybody wants to speak up at this time. We can also.
Yes, we have one person actually that raised a hand. Let me unmute this person.
Okay.
Hopefully, this person is still online. No, I don't see.
There are also some written questions.
Yeah.
Person, okay. So move to Q&A written on in Q&A box.
Yeah. So I also, guys, one question is around how realistic is it to move to use cars powered to electrical cars when there is already an energy problem in the in the network.
Well, there's not an energy problem in the network.
Exactly.
Not in Europe.
No.
There is a more generation than we could use at peak times. There is, though, a problem in some states in Europe where not every grid company wants you to take your own power from other suppliers. But there is no shortage of power. The moment you generate power in Portugal in a nanosecond, it's in Finland. So there is enough. And basically, look at it differently. To a electrified car is basically a driving saving account. Because when you charge your battery with your solar power on the roof, you lower your cost for driving, and you also could sometimes take extra power in your battery for which you're being paid. It will take too long to explain it in a minute, but there is sufficient amounts of power, and it is increasingly drastically. Look at Germany, look at the Netherlands. More power generated by solar and wind than by the coal-fired power plants in Germany at the moment.
Yeah.
Especially
the problem is it's not coming always at the same time. That's the problem. I think,
it's not a problem because the storage facilities, exactly, the storage facilities, hey, you can switch off your wind farm. You can switch off your solar when you have the proper technology in place.
Yeah. Hey, another question is, and it's a nice one from Thomas Brazilka. I see the big task is to educate responsible people, decision makers at companies about these consequences. What do you think, and what are your experiences how to educate them to let them realize this the right decisions? So how do we work with the decision makers, the CFOs, the CEOs in making the right decision and understand this game basically?
Don't start. And from my experience, you need to be at the top of a company and you need to be really at the floor of the company. If those two angles of the company are not involved, it won't work. The moment you have convinced the people in the company, from upstairs, from the corner office down to downstairs, is going to work. Because it's simple. Technology is fun and making money is even more fun.
Yeah, no, totally agree. Can't disagree with that one. There was Stefano, frequency variation. You explained that.
Sorry.
I will repeat the question because I think we lost the connection with Frans. What would cause a variation in frequency variation? Is it?
Yes, let's say that this is a little bit complicated topic, but in very few words, the frequency variation may be caused by different cause. First of all, as Gerrit mentioned, the fact that the grids were designed to have just one production point and a lot of consumption point. And in that case was very easy to manage frequency because there was just one generation point, and by controlling simply put the output of the motor or the generation point, you can control the frequency. Now we are going to a model where the generations point are more distributed all over the countries or over the nation, and you have a lot of power plants, solar plants, cogeneration plants, wind farm, etc. And you have to connect all these points that should be all rated at 50 hertz for European standard, but sometimes it's difficult to manage properly the frequency problem of a solar panel that is by definition not very modular. Okay, it's either on and off, or even to manage the output of a wind turbine. Okay, so all these problems are creating, all these different sources are creating problems in managing the frequency, even if from a European point of view, the frequency difference is very tiny. Okay, we are talking about percentage points, about 50 hertz, so we can talk about 49.9 or 50.1 frequency variation, but this is a problem that will be increasing in the next future because of the transition that Gerrit mentioned about decentralized power generation and the movement from a normal grid to a smart grid where everybody is exchanging energy with everybody. And so expect these problems to be magnified in the next future.
Okay. Thanks, Stefano. Hey, there was one other question. I will just answer it for you because, because of time, we need to stop. But there was also a question about, because of your case, that is this only for large companies? I think
no.
We can.
Yes, I showed you a business case of a large company for the sake of the numbers, let's say, but we are working with small company as well. So we are starting from what we call small business, from 20 kilowatts, so any very small shops to large industries. So we have different models of machines that will adapt to the situation of the customer.
Thanks so much. Okay, so yeah, we are at the closing time, let's say, of the webinar. So I would like to first of all thank you all for joining and participating to this first one of ours, and hopefully not the last. If you have any more questions, please ask them to us. We have a mail address, info@ensav.com, or in any other way through LinkedIn. We invite you, of course, to discuss these topics further with us, and also to follow us on LinkedIn. We have our own LinkedIn page, and you can follow us, and we also post there additional information about some of these trends. I hope you enjoyed, and I hope you have a great rest of the day. Thank you.